So welcome back to the channel. It's always a pleasure to have you back here again. This is still Pendulmatics. I am Pendulum. I'm your tutor on this channel, and this is where we break down mathematics, making it easy as possible for you to understand. This is the complete online school of mathematics, and it's good to have you back here again. We are still looking at indices, logarithm, and sorts, and we're done with the indices part. So we'll be moving into logarithms today. Logarithms is a big long, so we may have quite a couple videos on logarithm. Alright, so you're welcome. If you're new to the channel, do well to subscribe and turn on our notifications. Ring that bell so that you won't miss any of our videos. Our videos are always very detailed and very insightful, very educating. Alright, so we'll be looking at the laws of logarithm and the relationship between indices and logarithm in this video. So please, as we go on, I enjoin you to like the video. Okay, it's going to help with the algorithm so that other people can see it. Then drop your thoughts in the comment as well. Let me know what you think about the video and if it was helpful. Most importantly, share the video to everyone you can share it. Put it on your WhatsApp status, share it to your friends, share it in your class groups, share it to your classmates, and all of that. Alright, so welcome. Let's go ahead. We're looking at the laws of logarithm. So I've already written them on the board because I want to save us time. I don't want to be writing it as I'm teaching. So I'll just explain them and you will understand it. Alright, so let's go. First of all, we have the addition law. Now, basically the law states that if you are adding two logarithms, okay, if you're adding two logarithms, you have log m base a plus log n base a. If they have the same base a, the law states that you can take one of the logs, log a, and then multiply the powers, or multiply these numbers. Alright, so if you're adding two logarithms that have the same base, you can take one of the logs and then multiply the numbers in front of the log. Alright, so for instance, if you have log 2 base 6 plus log 3 base 6, how you resolve it? You pick one of the base 6 since they are the same, and then you multiply these numbers in front of the log. So you have 2 times 3. Alright, so 2 times 3 is 6, so you're going to get log 6 base 6, which will give you 1. I'm going to explain how this gives us 1 very soon. It's a law as well. But what you should know from this first law, if you're adding two logarithms, their bases are the same, pick one of the logarithms and the base, and then multiply the two numbers in front of each log. Even if there are 4 logs, the same thing. Multiply all the 4 numbers as far as their bases are the same. Now we have the subtraction law. Subtraction law is just kind of like the inverse of the addition law. If you're subtracting two bases, two logarithms that have the same base, pick the log and the base and divide their powers. So it's like the opposite of addition law. Two logarithms just like this, log ma minus log n base a. Because they have the same base, I pick the log and the base, log a, and then I divide their power. So in this case, I have log 15 base 5 minus log 3 base 5. What do I do here? Since they are both in log base 5, I take logarithm of base 5, log base 5, and then I divide these numbers in front. So 15 divided by 3. Subtraction is division. Addition is multiplication. Alright, so 15 divided by 3 is 5. Log 5 base 5 is 1. So this is how you resolve addition and subtraction in logarithms. When we start solving logarithm questions, you will see all these things coming into play. Now, why have I been saying log C6 is 1, log 5 is 1? Simple. Logarithm of any number to its own base is 1. The logarithm of any number to the same base is 1. So log a base a is 1. The logarithm of the number a to base a is 1. Alright, so logarithm of 10 to base 10 is 1. Logarithm of 2 to base 2 is 1. Logarithm of 6 to base 6 is 1. Logarithm of 5 to base 5 is 1. Any number at all. The logarithm of that number to the same base is 1. Logarithm of 1000 to base 1000 is 1. Alright, so just have that at the back of your mind. Then we have the power law. Now there are two facets to this law, A and B. Now A states that if you have a logarithm to a particular base and that logarithm is raised to a power, in this case we have log m base A, then raised to power p. Okay, if the number here, the number in front of the logarithm is raised to a power, you can bring the power backwards. It's acceptable. So this can give us, if this p comes backward, p log m base A. You can bring the power backwards. So in case here we have log 8 base 2. If you have to solve this, resolve log 8 base 2. There are many ways to do it. Alright, but one of the easiest ways to do it is to express this 8 as a power of 2. So you have log 2 raised to power 4 base 2. Alright, now you can see that this is raised to a power. So from the power law, the first part of the power law, you can bring this 4 to the back. And so you get 4, then log 2 base 2 remaining. Alright, and then log 2 base 2, as we've said here, is 1. 4 times 1 is 4. So whenever you have something like this and you have a power, you can express in a power, remember that the power can come backwards without affecting anything. And then the second part of the power law, now remember this first one, our power was for the logarithm number, the number in front of the logarithm. But what if our power is in the base? What if we have log m base A raised to power p? So it's the base now that is raised to power p. In this case, you can also bring the power backwards. So here you bring it like this. Here you bring it like this. You can also bring the power backwards. But since you are bringing it from the base, it's going to be a reciprocal of the power. So it's going to be 1 over p. Then log m base A. So you just remove the power, bring it back. But if you are bringing it from the base, 1 over the power. If you are bringing it from the number in front of the logarithm, it just comes as a whole number. So in this case now we have log 2 base 8. I can express this as a power to get log 2 raised to power 4 in the base. Because 8 is 2 raised to, sorry. What am I doing? Sorry, 8 is 2 raised to power 3, not 4. Sorry, this is 3. Please don't mind me, that's an error. I'm doing 2 times 4. 8 is 2 raised to power 4. 8 is 2 raised to power 3. God, sorry. 8 is 2 raised to power 3. Alright, so I can bring this 3 back and it becomes 1 over 3. Then I'm left with log 2 base 2. Alright, and log 2 base 2 is 1. So 1 over 3 times 1 is 1 over 3. Okay, so just remember, if the power is up, you bring it back as a whole number. If the power is in the base, you bring it back as a reciprocal. Alright, then logarithm of 1. It's also important to note that the logarithm of 1 to any number apart from 1 is 0. Logarithm of 1 to any other base apart from 1 will give you 0. The logarithm of 1 to base 1 is 1 according to this. The logarithm of any number to its own base is 1. So if you do log 1 base 1, you get 1. But apart from that, any other number you take 1 to the base of is 0. So log 1 base 5 is 0, log 1 base 2 is 0, log 1 base 10 is 0, log 1 base 3 is 0, log 1 base 100 is 0. Logarithm of 1 to any other number apart from 1 is 0. That's why we say that A here cannot be 1. For any other number, the logarithm of 1 to the base of that number is 0. Alright? Then we have the reciprocal law. This just states that I can rewrite this logarithm log m base A as, if I want to get the reciprocal, it will be 1 over. Then I change the position of this. Alright, so reciprocal of this is 1 over log a base m. So the a goes up, the m comes down. That's the reciprocal. So you do something like this probably in a case where you want to bring the base here down and you want this base to go up. So maybe in a number, in a case where you are solving, and let's say you have, because all these things you need to apply them where they will help you solve. So let's say you have a question like log 3 base 4, and the other one that you are solving is log maybe 5 base 3. If you have a question like this, log 3 base 4. Okay, let me just clean so that you can see what I'm doing, because this is quite small. Okay, let me continue here. If you have a question like this, log 3 base 4 plus log 5 base 3, consider these are in different bases. So you can't apply this. You can't apply addition law because they're in different bases. So one of the things you can do, if you apply the reciprocal here, that means I can write this one as 1 over log. Then the 4 will come up and the 3 will come down. Plus log 5 base 3. Okay, so you can see now that they are both in the same base, and then it makes it easier for you to solve. Alright, it now makes it easier for you to solve these two. So this is one of the cases where you can apply reciprocal. When you see that, okay, the base here is actually up in the other question, so you can use reciprocal to change it and bring it down without ruining the question. So take note of this. Like we have here, log 9 base 3 is equal to, if I use reciprocal, 1 all over 3 will go up, 9 will come down. So log 3 base 9. I can write 9 as 3 squared. And following this second power law, if I move the 2 here, it becomes 1 over 2. Because it's from the base. So 1 over 1 over 2 log 3 3. Log 3 3 is 1. 1 over 1 over 2 is 2. So this gives me 2. You also find that if you solve this one directly, log 9 base 3, if I write 9 as a power of 3, it will give me log 3 square base 3, right? If I bring the 2 back, I have 2 log 3 3, and log 3 3 is 1, so I will still get the same 2. So if you express a logarithm as an inverse, it doesn't change anything. Take note, it's just to put your question in a different format that may help you solve it. So a format like this, where you can now have the two of them in the same base to help you solve it. All right. Now we have change of base. Change of base. That's the last law. Now, what if you want to change a logarithm from one base to a completely different base? It's a bit different from this reciprocal, because reciprocal you are restricted. You cannot actually change to a different base. You can only interchange the position of the two numbers here. Alright, so you can, in this case now, you're only restricted to using 3 4 5 3. I can only say, okay, I want to bring 3 down and take 4 up, then I take the reciprocal. Or I want to bring 5 down and take 3 up, I take the reciprocal. But I cannot bring in a new number, I cannot bring in a new base if I'm using this. So that's where this change of base law comes in. Alright, now change of base law means if I have log m base a and I want to change to a completely different base, maybe the second number I have is something in a completely different base, I want to change it to its completely different base, I can introduce a new base, and to do that I will have log m to the new base all over log a to the new base. This is how you change base. So log m will be to the new base, so whatever the new number, the new base you are changing to, divided by log a to the new base. So you now have one logarithm like this will be split into 2, and you now change this thing to base y base y. Alright, so for instance, if I have log 3 base 4, I have log 3 base 4, and I want to solve this, this is going to give me, if I want to change to base 6, it's going to give me log 3 base 6 all over log 4 base 6. So now I've changed this logarithm to base 6. Alright, so there are places where you can apply this change of base to help you, and I think we'll do that maybe in our next video when we start looking at examples properly, where all these things are applied to solve questions. Alright, but to end for this video, let me just expand on the relationship between indices and logarithm. Alright, so with this I will end the video. Now, indices and logarithm are related by this relationship here. Alright, if log y base a is equals to x, logarithm of y to base a is equals to x, that's a logarithm. If I want to convert it to indices, I say that a raised to the power x is equals to y. So the base raised to power of the number after your equality sign is equal to the number on top of the logarithm. Alright, so if log y is equals to x, therefore a raised to the power x is equal to y. Alright, so the base for the logarithm remains the base for the indices. The answer for the logarithm becomes the power for the indices, and then the number on top of the logarithm becomes the answer for the indices. So if, for instance, you have log 4 base 2 and you want to solve it, all right, one way to solve it, you put it equals to x and then you convert to indices. All right, there are two ways to solve it actually. The first way, if you neglect this x, log 4 base 2, now you can express 4 as a power of 2, which will be log 2 square base 2. If you bring the 2 on top back, you have 2 log 2 2. Log 2 2 is 1, so the answer is 1. See what I mean? I mean you can write this as log 2 square base 2. That's this. Alright, and if I bring this 2 back, I have 2 log 2 2. Log 2 2 is 1. 2 times 1 is 2. So that's the first way to solve it. Then the second way, if I want to relate it with indices, log 4 base 2 is equals to x. From this, you have that 2 raised to the power x will be equals to 4. The base 2 raised to the power, raised to the answer x is equal to 4. Now, I've translated it from logarithm to indices. Alright, so this is now indices, and you can solve it the same way I've taught you how to solve indices. So 2 raised to the power x is equals to 4 is 2 square. Alright, and since the bases are equal here, I can cancel out the bases and I have that x is equal to 2. So you can see that the same answer. So this is the relationship. If you keep this in mind, you can always move between indices to logarithm, logarithm to indices. So that means if you have something like this, for instance, log 3 base 9 equals to x. If you want to convert this to indices, all you do is the base still remains the base, raised to this power x is equal to 3. Alright, now it's in indices form. So you can now solve it here to get your value of x. Alright, so it's quite simple. It's quite simple, at least at this stage. So if you found this video helpful, please remember to like the video. In the next video, we'll look at examples of how we can apply all these things. So this is just to introduce you to the laws of logarithm and the relationship between indices and logarithm. Don't forget to drop your thoughts in the comments. Let me read from you and know what you think. And share this video very far, very wide with as many people as you can share it with. Alright, I'll see you in the next video shortly. Keep learning, keep studying, subscribe to this channel, and don't forget to turn on our notifications. Alright, thank you very much.